Hi everybody, welcome to the third video in the series of lectures on algebraic expression, and in this section we are going to look into what do we mean by a cube. So when we say a cube, what we imply is let's say instead of a cube we say, hey, 3 cube, a is 3. So what we imply is this is 3 into 3 into 3. So if I ask you how many little cubes are there in this big cube, this is a 3 cube. So you have 3 on this side, and you have 3 here. So you have total of 9 cubes in this layer, and you have 3 layers like that. So here, if you look at here, you have 3 layers. So you have 3 into 3, which is 9, and into 3 again. So that's about 27. So in this, you have 27 cubes, right? So when I say 3 cube, that's what I mean. And here in this one, this is a bigger cube, which is 8 cube. So this is 8 cube. And that would be 8 into 8 into 8. That's equal to 64 into 8. That's 32 for 512. So you have a total of 512 cubes in this big Rubik's cube. Now, we do have expansions just like in squares. We can say, hey, can I add cubes into the 3 by 3 cube and make a 8 by 8 cube? Of course you can do that. So you can do that by adding 5 cubes everywhere. So that means that on this side you have to add 5 more cubes, and here also you need to add 5 more cubes, and once you add 5 more cubes there, you need to add 5 more cubes there also. Right? So you add 5 cubes everywhere. 5 from here you add another 5. From here you add another 5. So everywhere you add 5. And that's what we mean by saying 3 plus 5, the whole cube. Of course, we know that this is 8 cube and 512. But we can look at this 3 plus 5 cube visually by breaking it up and looking as different parts. Just as we took a square in the previous video and of side A and added B to it and made a bigger square. So basically what we did is we added B to both these sides and made it a bigger square, and we tried to decompose this big square. So just as we did in the previous video and found out an expression for a plus b the whole square, one can wonder if there is a similar way you can imagine for cubes. That is, you start with a cube, so of side A and depth A, and you add a section B. And is there any way you can add B and then you can further decompose this cube just the way you did in square? So this is a cube that you find when you add B. So this cube is nothing but a plus b the whole cube, or a plus b the whole cube. So this cube that we see is a plus b the whole cube. It's hard to visualize the various parts of this cube. So if you were to break open this cube into different parts, you can see the various parts as shown in this figure. So what you have is you have this side, which is A, and this is B, and this is A. So these blocks are A squared, which is A squared B. So that is volume of this. And same as with this as well. So this also would be your a squared b, and this also would be your a squared b. I leave it to your imagination to imagine and convince yourself that all these three would be a squared b. And this would be, this side is b, and this is a. So all these blocks are a b squared. So you have a b squared, a b squared, a b squared. So far you have, what you have done is you have said a plus b, the whole cube, is nothing but, you have 3 times a squared b. So you can write, this is 3 times a squared b plus 3 times ab squared, 3 times ab squared, 3 times ab squared, plus here you have b. All the sides are of side b. So you have a b cube, plus, and you have a cube which is hidden deep inside. So this is your a cube. So plus a cube. So this would be your expansion of your a plus b the whole cube. You can also imagine this as, if you want to do it algebraically, this is a plus b the whole cube is nothing but a plus b into a plus b the whole square. That would be, that's this whole square in the front. That would be a plus b into a squared plus 2ab plus b squared. You can further expand this by treating this as one unit and say that, hey, this is nothing but a times that unit plus b times that unit. And that would be a cube plus 2a squared b plus ab squared plus ba squared plus 2ab squared, which is basically you're multiplying b with this, and then finally b cube. And there you go, you get the above expression, which is 3a squared b plus 3ab squared plus a cube plus b cube. So that's a visual and algebraic definition of a plus b the whole cube. If you would like to derive what is a minus b the whole cube, all you need to do is to substitute minus b in this equation and see what happens. So if you have a plus minus, instead of b you can put it as minus b the whole cube would be, you can directly go here, which would be a cube plus minus b the whole cube plus 3a squared minus b plus 3a minus b the whole square. That would be a cube minus b cube. You can take minus 3ab outside, and what you will have is into a minus b. So that's an expression for a minus b the whole cube, which is also something you should know it. And in the next video we will solve some of the problems using this basic expression of cube. Until then, ciao.